Hello class, welcome to this session. We're going to look at an example which touches on a resistor and an inductor being connected in series to a voltage source. And the question reads, a coil of inductance 318.3 millihenries and a negligible resistance is connected in series with a 200 ohm resistor to a 240 volt 50 hertz supply. Calculate the following. Part A, the inductive reactance of the coil. Part B, the impedance of the circuit. Part C, the current in the circuit. Part D, the PD across each component. And part E, the circuit phase angle. So basically this is the question we are going to answer. Whenever you are given such a question, it is always prudent for you to come up with a circuit diagram. You connect the three components. Remember, we have been given a voltage source, we have been given a resistor, we have also been given an inductor. So these three components is good for you to put them in a circuit for easier understanding on what you are supposed to do. So once you have done that, it's always prudent for you to come up with a phasor diagram. Like I've said before, in the phasor diagram, the current I, this I, will be the same across the two components, hence it shall be taken as the reference phasor. So on the horizontal axis, this line, your current is presented there. Once you do that, you will now come the voltage across the resistor. Voltage across the resistor is always in phase with the current, meaning the voltage follows the current and they are drawn on the same line. And the current, since the current is drawn on the horizontal line, so therefore the voltage also is drawn along that line. The next thing is to draw the voltage across the inductor. Voltage across the inductor is also drawn on the vertical axis, and of course it will now be able to form a voltage triangle. But for easier calculation, we can come up with an impedance triangle. And I said this before, that in an impedance triangle, it has got three parameters. It has the resistor across, it has the resistor. Number two, it has an reactive. The impedance triangle has the three parameters. It has the resistance, which is drawn on the horizontal axis. It has the reactance that is drawn along the vertical axis, and of course the hypotenuse of that triangle forms the impedance. So you can now be able to see for you to come up with the impedance triangle, you must know the value of the resistance, you must know the value of the reactance. So the most important thing here is for you to get the resistance. The resistance is directly given there. The resistance has been given as the resistance has been given as 200. The inductive reactance is given by the inductive reactance XL has been given as 2 pi FL. Remember, the frequency has been given as 50. And you can see there, the inductance has been given as 318.3 millihenries. You need to change that to henries by dividing by 1,000, or you need to multiply it by 10 power negative 3. If you divide it by 1,000, you will get 0.3183. So this value has been obtained by dividing it by 1,000. You can see here our inductance was 318.3 millihenries. You divide by 1,000, you will get 0.3183 henries. So once you get that, we can now move on. We have obtained the resistance to be 200. We have also gotten, so the inductive reactance XL given by 2 pi FL, once you substitute these parameters, you will get 100. So the inductive reactance is 100. Once you have gotten the reactive reactance to be 100, it is presented along the vertical axis, because reactance is always presented along the y axis. So this one is presented along the vertical axis or the y axis. Resistance is presented along the x axis. So once you do that, you can use Pythagoras. D squared plus D squared should give us D squared. So the impedance is given by R squared plus this x squared plus R squared. So once you tabulate that, once you calculate that, of course, you will be able to get the impedance as 22.361 ohms. We go to current. In this case, current will be given by the voltage divided by the impedance. Remember, impedance is now the combined opposition of those parameters or the components connected in the circuit. So voltage over Z. So 240 is the voltage divided by the impedance. If you divide 240 by this, you get 1.073 amperes as the current that is flowing in the circuit. Remember, this current is the same. It is the current that will flow across the resistor R. It is the same current that will flow across the inductor L. We now move to D. The potential difference across the coil VL is given by the current multiplied by the inductance L. Of course, you can see there, if you take the product of these two, the current is 1.073. This current, bring it here. XL, remember, was our inductive reactance. We got it up here. This is where we got it. Our inductive reactance was 100 here. So if you bring it here, of course, you multiply by this, your answer becomes 107.3 volts. That is the potential difference across the coil. The potential difference across the resistor, voltage is given by current multiplied by the resistance. Remember, the current is this multiplied by the resistance, you get this. One thing you have noted is the same value of current. So if you move to the circuit, it means the current passing across this is 1.0. This current is the one that will pass here and is the same one that will pass here. So the voltage across this is given by the current multiplied by the resistance. The voltage here will be given by the same current multiplied by the inductive reactance. So once you ascertain all that, you can now move to the angle. If you want to get the angle, remember we said from the phasor diagram, we have now obtained these two. This angle is obtained using tan. Tan is given by opposite of adjacent. So meaning it is 100 divided by 200. So from our formula, if you move down there, you can see tan is given by XL over 100 over R. Remember, our XL is 100, our R is 200. So if you want to get tan, you will take tan inverse of XL over R. So that one gives us tan inverse of 100 over 200. You use your calculator, of course, you will be able to get 26.57. So we can say the phase angle phi is given by 26.57 lagging. We are using lagging because we are talking of an inductive circuit. Inductive circuit is said to be lagging. Remember, our point of reference is current, and we know that in an inductive circuit, current lags. Remember, this angle is always attached to the current. If it is a capacitor, we could say the angle is leading. It is that angle leading, because we expect in a capacitor current to lead. So basically that angle is always mentioned, or this word is mentioned with reference to the current. Is the current leading? Is the current lagging? So basically that is what is expected of you whenever you handle these questions. Thank you.